Welcome back. Today's lesson is going to be on solving quadratic inequalities. So not only can we have quadratics and not only can we have inequalities, but we can put them together as one and solve. Enjoy that rippling water there for a second. And let's dive in. Just a few reminders when we are solving inequalities and we write our solutions. We have anything that is just less than or greater than, parentheses. If it's equal to, it's brackets. When using interval notation. So a reminder of that from way back in. So we're going to solve the quadratic equation, find the intervals that are determined by the solutions, and then use a test value to determine which intervals form the solution set. For this last step, you plug the test value into the original inequality to see if it is a true or false statement. All right. Best way to do this is just jump right on in. Here we go. I'm going to ignore the inequality for right now for this first example. And I'm going to solve this as if I had equals 0. So the important thing is that we do have 0 over there on the right side. Just like if we were solving, we want it to be equal to 0. Inequalities, we have to have a 0 that's there. We can solve this quadratic by factoring, completing the square, or quadratic formula, your choice. I always start with looking for a greatest common factor. This does not have one. So 1 times negative 12 is negative 12. The factors of negative 12 that add to negative 1 are positive 3 and negative 4. Oops. Sorry about that. So factoring, I'm going to bring down x squared. That's a positive 3, so plus 3x minus 4x minus 12. Split that in half. Greatest common factor on the left side is x. Leaves us with x plus 3. The right side starts with subtraction, and the greatest common factor on the right side is 4. Be careful with your signs. Remember that you're dividing both of those by a negative 4, which makes that a positive x and a positive 3. So these two are my new like terms. And then x minus 4 is what we pulled out. Solve for x. We would subtract 3. X is equal to negative 3. Add 4. And x is equal to positive 4. That's our first step. We just solved. So let's label that step 1. Step 2. Let's get this on a number line so we can figure out what our intervals are. So intervals, remember, are chunks of data or numbers or something that gives us an idea of where we want to be. So I know I need a -3 and a +4. If x is equal to -3, then here's one cutoff. And if x is equal to 4, here is another cutoff. So if we label this section, this is -infinity to -3, because this section goes from -3 to that arrow. The middle section goes between 3 and 4. So that'd be -3 to 4. And then the last section goes from 4 to the end here, which is an arrow. So that's 4 to +infinity. Please remember that I am using parentheses because our inequality was less than, not less than or equal to. And so that's why the numbers have parentheses. And then the infinity signs always have parentheses because we don't know exactly what infinity is. All right. That's step 2. Step 3 is testing your intervals. So we have the interval, pick your test value, and then true or false. Our first interval that we listed up on our number line was -infinity to -3. So we can make our test value anything we want between -infinity and -3. Can't be -3 though, because it's not equal to. So let's pick -4. That means we're plugging in -4 to the equation. So we have -4 squared minus -4 minus 12, and that has to be less than 0. Well, -4 squared is 16. -4 minus -4 is actually +4. Minus 12. 16 plus 4 is 20. Is 20 minus 12 less than 0? No, that's false. So that cannot be part of our answer. My second interval that I listed was -3 to -4. So we can pick absolutely any value we want as long as it's in between -3, +4, sorry. That's a +4. And of course, we always like to bring in 0 wherever we can. That makes it super easy because when we plug that into our equation, we have 0 squared minus 0 minus 12. Well, 0 minus 0 is 0, and 0 minus 12 is -12. Is -12 less than 0? That's true. So we can have the middle part. The last part is that 4 to infinity. So we can pick any number we want between 4 and infinity. And I'll just go ahead and pick 5. We have 5 squared minus 5 minus 12 is less than 0. 25. Negative 5 minus 12 more is negative 17. Is 25 minus 17 less than 0? Nope, that's false. So we can't have that part either. That makes our grand total solution the interval of negative 3 to 4. These take up lots of space, so don't be surprised if it takes you a couple sheets of paper to work on these. All right, let's try the next one. We're solving x squared minus 2x minus 15. So I'm going to start over here with step 1, which is to solve. When we're solving, we're pretending that it's equal to 0 rather than having the inequality. So it's equal to 0. Great. We can either factor, completing the square quadratic formula. If I factor, is there a GCF here that I can pull out? Nope. So 1 times negative 15 is negative 15. The factors of negative 15 that add to negative 2 are negative 5 and positive 3. X squared minus 5x plus 3x minus 15. Split that in half. Our GCF on the left is x, leaves us with x minus 5. The right side starts with plus. Our GCF on the right is 3. That leaves us with x minus 5. My parentheses are the same, so we have x minus 5 as our new common factor, x plus 3 as our leftovers. Remember, these are equal to 0, so we set each part equal to 0 and solve for x. Add 5 to both sides when we get x is equal to positive 5. Subtract 3 from both sides and we get x is equal to negative 3. Make our number line. Let's see, negative 3, negative 1, 1, 3, 5. All right, so with solutions of 5, there's one of our dividing points, and negative 3, there's the other. That means that this left side goes from negative infinity to negative 3. Oops. Let's make that look a little nicer. And then our equation here is equal to. So that means our negative 3 gets a bracket. Our middle part here goes from negative 3 to positive 5. Again, they're brackets because of the equal to. And then on the right side, we have from 5 to positive infinity. So bracket 5, infinity parenthesis. Those are the intervals that could possibly be our answer. And that's where we set up our testing. So we have our interval, our test value, and then true or false. We start with the negative infinity to negative 3. Again, anything you want to plug in is fine. I'm going to go ahead and plug in negative 4. Remember, we plug that value into the original equation. So we have negative 4 squared minus 2 times negative 4 minus 15, and that all has to be less than or equal to 0. 16 plus 8 minus 15. That's 24 minus 15. 24 minus 15 is a positive number, so that's going to be false. I can't have that interval. For the middle, from -3 to +5, I'm going to go ahead and take 0. We have 0 squared minus 2 times 0 minus 15. All of this is 0. So is -15 less than or equal to 0? True. So we can have that middle part. Our last interval to check is the 5 to infinity. And I will pick 6. So we have 6 squared minus 2 times 6 minus 15. That's 36 minus 12 minus 15. 36 minus 27. And is 36 minus 27 going to be less than or equal to 0? Nope, it's not. So that means that our solution, the only thing we can possibly have, is going to be -3, 5. Make sure it's in brackets because of the equal to. Example 6. We're still doing the same 3 steps. Start with solving. 2x squared plus 5x minus 12 is equal to 0. You probably want another piece of paper after this, so you've got room for that second example, because the back probably will take us a little bit of space as well. All right, greatest common factor over here, nope, equal to 0. It is your choice. Again, factor, complete the square quadratic formula. I love factoring, so I'm going to go ahead and factor. 2 times -12 is -24. Factors of -24 that add to 5 are 8 and -3. So I have 2x squared plus 8x minus 3x minus 12. Split that in half. I should label this as step 1 over here. Our greatest common factor on the left is 2x. That leaves us with x plus 4. The right side starting with a negative or subtraction, and our GCF is 3. Remember, we're dividing by -3, so signs are changing. X plus 4 then is our new common factor, and we pulled out 2x minus 3. Remember, all of that is equal to 0. So x plus 4 is equal to 0. 2x minus 3 is equal to 0. We have x is equal to -4 and positive 3/2. Step 2, I'm going to make my number line. And so my dividing lines there, we have -4 and positive 3/2, which is 1.5. It's going to be halfway in between there. Writing what those intervals look like then, we have this direction. That's -infinity to -4. This is equal to, so that 4 is getting a bracket. In the middle, -4 to positive 3/2. And again, they get brackets because of the equal to. And then at the end, we have that 3/2 to positive infinity because of the arrow. purple. So step 3, we have our interval, our test value, and then true or false. Our first interval then is -infinity to -4. Again, pick any test value you want between those. I'm going to pick -5. We plug that into the original equation, which in this case will be 2 times -5 squared plus 5 times -5 minus 12. And we want to know, is that going to be greater than or equal to 0? I plop all of that into my calculator, or I can do it step by step. And we end up with 13 is greater than 0, which is true. So that's a good part of our answer. In the middle, we have -4 to +3/2. Any value in between there, and again, I'm probably going to pick 0. That's 2 times 0 squared plus 5 times 0 minus 12. And we do all that math, we end up with -12 is greater than 0. That's false. -12 is not greater than 0. So we cannot have the middle. Our last part will be 3/2 to +infinity. I picked 2. 2 times 2 squared plus 5 times 2 minus 12 is greater than or equal to 0. I do all this lovely math and I get 6 is greater than or equal to 0, which is true. So we can also have that last part. How do we write that solution then? That solution will look like -infinity, oops, having a little issues with that there, sorry, to -4, union, remember when we skip over stuff, that's a union, 3/2 to infinity. Second example, step 1. We are solving. So 3x squared minus 11x minus 4 is equal to 0. Is it equal to 0? Yep. Is there a common factor that we can pull out between 3, 11, and 4? Nope. Again, your choice, factor, completing the square, quadratic formula. I'm going to go ahead and factor. 3 times -4 is -12. The factors of -12 that add to -11 are 1 and -12. We have 3x squared plus 1x minus 12x minus 4. Greatest common factor over on the left is x, leaves us with 3x plus 1. Second half starts with subtracting. Common factor on the right side is going to be 4. That leaves us now with a positive 3x and a positive 1. 3x plus 1 is our new common factor, and we pulled out x minus 4. Set those equal to 0 and solve for x. We get x is equal to -1/3 and x is equal to positive 4. Put this out on a number line just to get a feel for where our boundaries are and where our testing should go. Let's see, I'll do and let's see, -1/3 is roughly about right there. Positive 4. So writing our intervals, this is not equal to, so they will be parentheses. This way is going to negative infinity, so negative infinity to negative 1/3. The middle is 1/3 to 4. And then the right side is going from 4, and then the arrow is positive infinity. So that gives us our intervals for our test values. So we have interval, this is step 3, interval, test value, and true false. Our first interval, negative infinity to negative 1/3. I am going to make that test value negative 1. 3 times negative 1 squared minus 11 times negative 1 minus 4 has to be greater than 0 to be true. And I do all this math. I end up with 10 is greater than 0. This is true. So that first interval is good to go. We can have that in our answer. In the middle, we have negative 1/3 to 4. Love having the ability to pick that 0. So 3 times 0 squared minus 11 times 0 minus 4. All of that leaves us with negative 4 is greater than 0. That is false. So we can't have the middle. On our last interval from 4 to positive infinity, I'm going to make that test value 5. So 3 times 5 squared minus 11 times 5 minus 4. We end up with 16 is greater than 0. That is also true, so we can have that last part. Our solution then will be negative infinity to negative 1/3 union 4 to infinity. At the bottom here, we have that the greater than and less than symbols are called strict inequalities and non-strict inequalities. Just some more vocabulary. We're not going to really worry too much about the vocab right now. Let's worry about solving. Go ahead, flip it over to the back of your notes. And our last step is talking about the height of something that we are launching. We have an equation of s is equal to negative 16t squared plus 96t. And we want to know when this will be greater than 80 feet above the ground. And it says its height is s. So we want negative 16t squared plus 96t to be greater than 80. All right. If we're following our steps, step 1, we ignore the inequality and we have to solve. So we have negative 16t squared plus 96t is equal to 80. Well, remember, we can't do anything with quadratic formula or factoring unless it's equal to 0. So I am subtracting the 80. Now that it's equal to 0, I want to find a greatest common factor. Our greatest common factor for this is negative 16. So we're dividing everything by negative 16. And that gives us t squared minus 6t plus 5 is equal to 0. Let's factor. 1 times 5 is 5. The factors of 5 that add to negative 6 are negative 5 and negative 1. Factored form, we have t minus 5 and t minus 1 is equal to 0. T minus 5 is equal to 0. T minus 1 is equal to 0. So t is equal to 5 and 1. All right. Step 2. We have our interval between 1 and 5. So 0, 2, 4, 6. And drawing at 1 and 5. So this is negative infinity to 1. This is not equal to, so it's parentheses. The middle, we have 1 to 5. And on the right side, we have 5 to infinity. So we want to now go to our third step, where we have our interval, our test value, and true false. Before we do this though, remember back here when we took out our greatest common factor and we divided by negative 16. What happens to an inequality when we divide by a negative? It changes direction. So this inequality is actually going to be negative 16t squared plus 96t minus 80 is less than 0. If you're comfortable with it, you can use the reduced form of t squared minus 6t plus 5. So I can pick any value I want for the interval between negative infinity and 1. I'm going to go ahead and pick 0. Plug 0 in. I'm going to plug it into this new equation there. And we get 5 is less than 0. That is not true, so we cannot have that first part. For the interval of 1 to 5, I'm going to pick 3. When I plug in 3, I get negative 4 is less than 0. That's true, so we're allowed to have that middle interval. And for 5 to infinity, I'll pick 7. I know I threw you off. I didn't pick 6. I picked 7. Plugging that in, and we get 12 is less than 0. That's false. So that means that our overall solution for when our ball or lawn dart or whatever it is that we're tossing is going to be more than 80 feet above ground is going to be between 1 and 5 seconds. That's it for today. Thanks so much for joining me. I hope you have a great evening.